Math 1314, Tyler Junior College, Section 2.8, Distance, Midpoint, Circles. The distance formula, part 2. In the previous video, we used the Pythagorean theorem on a picture of two generic points, x1, y1, x2, y2, to derive a formula to calculate the distance between the 2 points. The distance equals the square root of the sum of the squares of the differences. Now, if this formula is a little bit intimidating, you can rewrite it as distance equals the square root of the run squared plus the rise squared, as long as you remember how to calculate the run and the rise. But for these two examples, I'm going to be using the formula that contains x1, x2, y1, and y2. Let's start by calculating the distance between the points -4, 1 and 1, 13. At some level, mentally, verbally, or writing it, not sure the adverb to go there, you need to identify who is who. For example, -4, we can call it the first x. We could also call the 1 the first x because the choice is arbitrary, but let's go with this. The moment you name -4 as x1, everything else is named. If this is your first x, then 1 is your first y. This 1 is your second x, and 13 is the second y. So to get the distance, all we have to do is grab the distance formula and start substituting values. One way to attack the distance formula is to write it with no variables, but preserve the structure. The distance is the square root of the sum of the squares of the differences of corresponding coordinates. This is the structure. Now we just got to drop the numbers in. According to the formula, the second x goes here and the second x is 1. The first x goes here and the first x is -4. Watch your signs. The second y goes here and that's 13. Then the first y goes here, which is 1. You just follow your order of operations. First move, subtract the coordinates. Watch your double negative. 1 minus -4 is 5. 13 minus 1 is 12. That's easy. If you're tempted to cancel the squares, don't. You still can't distribute the square root across an addition problem. The square root is the last thing you will do. 5 squared is 25. 12 squared is 144. At this point, I can go horizontally. 25 plus 144 is 169, and the square root of 169 is 13. The distance between the 2 points is 13. The distance formula doesn't usually go very crazy until the end, if it goes crazy at all. For example, in this last one, just for kicks, let's call 0 the first x. I know, normally you would call this the first x, but the order in which these points were written was completely arbitrary. I could have written this one first, could have been x1. So we'll do it calling this x1, which means y1, and over here, x2, y2. If you don't believe me that the order doesn't matter, then I invite you to rework the problem calling this the first point and see that we get the same answer. Let's go. Distance is the square root of the sum of the squares of the differences of the corresponding coordinates. Second x is 0. First x is -2. There's another double negative. Second y. Y'all see what I just did? The formula says second x goes here, and I just put what I saw was the second x, but wrote as the first x. So in my mind, it was thinking, you're the second x, even though I call it first x. I do want to set it up correctly according to my decision of calling this x1, so let me start over. Second x is -2. First x is 0. Second y is -7. First y is -1. Seriously, you should always just call the first point x1, y1, so you don't make a silly mistake like I just did. what I said earlier stands. The choice of who is first and second is actually arbitrary in this formula. All right. Subtract. Negative 2 minus 0 is negative 2. That will get squared. Negative 7 minus negative 1. Be very careful. Double negative here. So it's negative 7 plus positive 1. But when you add a positive and a negative, you subtract. 7 minus 1 is 6. And the larger number sign prevails. Since 7 was the larger of the two numbers, and 7 is negative, so is the 6. But you probably know it really doesn't matter. I mean, technically it does, but at this point it's going to get squared anyway. Negative 2 squared is 4. Negative 6 squared is 36. 4 plus 36 is 40. And at this point, we've run into a slightly different issue than we did in the first one. In the first one, we got the square root of 169, but 169 is a perfect square. When we square root it, it's an integer. It's a whole number. Not so for the square root of 40. Now, what should we do with the square root of 40? This depends upon your professor's preferences, and if this is a homework question, what your homework asked for. But there are two things in general you could be expected to do if you have a square root of a number that's not a perfect square. Number one, you could be asked to simplify it. Meaning, if you can't square root the whole thing, factor it into a product of two numbers, one of which is a perfect square. In this case, we could factor 40 into 4 times 10, and the square root of 4, of course, is 2. So that's one version of the answer. The other is to get a decimal approximation. And a decimal approximation simply means just put it in the calculator. Now, you could put the square root of 40 in the calculator, or you could put 2 times the square root of 10 in the calculator. If you work this correctly, these decimals should come out to be the same, which, by the way, is a calculator way to determine if you simplify a square root correctly. Both of these should have the same decimal answer. But if I'm just approximating the distance, then I really don't need to simplify the square root. I can just put the square root of 40 in a calculator. And we get to, we'll take it to 2 decimal places. The square root of 40 is approximately 6.32. The next digit is 4, so the 2 didn't round up. So in calculating distance, it's pretty straight shot from the beginning to the end. The only issue is when you get to the square root, will it or won't it? If it will, do it. If it won't, check the instructions to see if you're being asked to simplify it, or if you're asked for a decimal approximation. And by the way, not all square roots can be simplified. If this ended up being the square root of 30, believe it or not, the square root of 30 can't be simplified. Don't believe me?